Okay, good morning. In the previous video lesson, we have seen the conversion of voltage source into current source and current source into voltage source. And also we have seen few problems on that. Now let us see some more problems. So let us see this problem. Find a single source equivalent at terminals AB of the circuit shown below. Okay. Now convert, here there are two current sources, convert them into voltage sources. Sorry, two current sources are there, 5 ohms from B to A, and this is A to B. By applying KCL you will get 4 amperes. 4 amperes from B to A and 6 in parallel with 3. So by using R1 R2 by R1 plus R2, 6 into 3 by 6 plus 3, that is 2 ohms. So 4 amperes in parallel with 2 ohms. Similarly, second problem. Now by applying KVL, you will get plus 10, plus 2, plus 15, minus 10. VAB is equal to plus 2 by plus 15 minus 10. So 7 volts. And all the resistors are in series. So 2 plus 1 plus 3, 6 volts. 7 volts in series is 6 volts. Yes. For this one, here also single source equivalent circuit at the terminals AB, but one is current source, the other one is voltage source. So first you convert this current source into voltage source. So by converting this into voltage source, you will get 10 into 2, that is Vs, 20 volts, in series with 2 volts. So now VAB is equal to plus 5 plus 20, 25 volts. And resistors are in series 2 and 1. 2 plus 1, 3. Similarly, next problem is convert this voltage source into current source. So converting this voltage source into current source, 5 by 1, so 5 amperes from B to A in parallel with 1. 5 amperes, 1 volt, 4 amperes. So by applying KCL, we will get 5 minus 4, 1 ampere. From B to A, 1 ampere. 1 and 2 are in parallel. So 1 into 2 by 1 plus 2, 2 by 3 volts. Okay. Okay. Next. Next problem. Convert the following voltage source into equivalent current source. It is a AC network. So, you know that IS is equal to VS by Z. So, 50 at an angle 0 by 5 plus J7. So, by simplifying this, you will get 5.813 at an angle minus 54.46 amperes. That is current source value. In shunt with impedance, same impedance. That is 5 plus J7. Let's convert the following current source into equivalent voltage source. So this is IS into Z. Z is 3 ohms in parallel with J4. So 3 into J4 by 3 plus J4. This IS is this and this is Z. So by simplifying you will get 24 at an angle into 1.87 degrees. So this is VS value in series with this value is equivalent impedance is 2.4 at an angle 36.87 degrees. Now, yes. Next, Ohm's law. Ohm's law says that at constant temperature, the current flowing through the conductor is directly proportional to the applied voltage and inversely proportional to the resistance of that conductor. So mathematically, you can write it as I is equal to V by R. So V is equal to IR. Where V is applied voltage in volts, I is resulting current in amperes, R is the resistance in ohms. Okay. Ohm's law says that at constant temperature, the current flowing through the conductor is directly proportional to the applied voltage V and inversely proportional to the resistance of the conductor. So mathematically it is I is equal to V by R or V is equal to V I R. Okay, for AC network, I is equal to V by Z. So V is equal to IZ. Limitations. For nonlinear devices such as diode, transistor, etc., it cannot be applicable. It is applicable to the linear circuits only, linear elements. For metals which get heated up due to the flow of current through them, it is not applicable. For electrolytes, where enormous gases are produced on electrodes, for semiconductors, we cannot apply. For vacuum tubes, for gas-filled tubes, for arc lamps. So these are the limitations of Ohm's law. Kirchhoff's current law. It states that the sum of the currents entering a junction is equal to the sum of the currents leaving the junction. Or the algebraic sum of all the currents meeting at a common junction is 0. Okay. Sum of the currents entering a junction is equal to sum of the currents leaving the junction or OR. The algebraic sum of all the currents meeting a common junction is 0. For example, if you consider this is a junction. I1, I2, I3, I4, I5 are meeting at this junction. Now, according to the KCL, sum of the currents entering is equal to sum of the currents leaving. So I1 is entering current, I2 is also entering current. I3, I4, I5 are leaving currents. So I1 plus I2 is equal to I3 plus I4 plus I5. Kirchhoff's voltage law. It states the sum of the potential raises around any closed circuit is equal to sum of the potential drops in that circuit. Okay, that is the algebraic sum of the potential raises, the algebraic sum of the potential difference, the algebraic sum of the, here you correct this, the potential differences around a closed circuit is 0. Okay, note down. Next. So I is equal to V by Z for AC network. Next. Next. Here you correct this. It says that the phasor sum of potential differences around a closed network or closed path around a closed path is zero. Repeat. The phasor sum of potential differences around a closed path is zero. Now let us see this problem. Find I in the circuit given below. So by applying KVL, sum of EMFs is equal to sum of IRs. So sum of EMFs is, this is potential raise and this is potential drop, because current is entering here at the tail of the source direction. So this is potential raise. Here it is potential drop. So 20 at an angle 0 is equal to I plus 2I plus 30 at an angle 0. This is wrong, the solution. So I plus 2I is equal to 30 at an angle 0 minus 20 at an angle 0. Because the direction is opposite direction. If it is in the same direction as current, then you will take it as plus 30. Then you will take it as positive. Minus 20 plus 30. So minus 10, it should be minus 10. Minus 10 means 30 is 30 at an angle 0 is minus, 20 at an angle 0 is plus. So minus 10 at an angle 0 by 3. That is I. Now here the source direction is different. So this is potential raise. This is potential drop. Okay. So 30 at an angle 0 minus 20 at an angle 0 by 3. That is I. No, the solution is wrong. So you change that. Now here I plus 2y, I plus 2y plus 30 plus 20 is equal to 30. Is equal to 30. No, sorry. This is potential raise. So drop is I, drop is 2I. This is potential drop. No. Oh, correct only. Solution is correct. This is also potential. So 20 plus 30. Sorry. I thought it is this direction. So potential raise. This is also potential raise. So 20 plus 30 is equal to 2I plus I, 3I. So 50 by 3. Correct. This one. Potential drops is equal to sum of the potential raises. So these two are potential raises. Next, here sum of the potential this is potential drop because current is flowing plus 2 minus and here also plus 2 minus, so potential drop. So I plus 2I plus 30I plus 38 and angle 0 plus 28 and angle 0 is equal to 0. So 3I plus 58 and angle 0 is equal to 0. 3I is equal to minus 58 and angle 0. I is equal to minus 58 and angle 0 by 3. That is minus 16.66 amperes. So when the current flows from positive to negative, then it is a potential drop. When it flows from negative to positive, then it is a potential raise. In the previous problem, both are potential raises. Here, both are potential drops. Next, determine the current through resistor R3. That is I3. The circuit shown below. So total current is 50 milliamps. Suppose if you consider this junction, all the currents are meeting at this junction. At this junction. So currents, some of the currents entering the junction is equal to some of the currents leaving the junction. So 50 is equal to entering current is equal to 30 plus 10 plus I3. 30 plus 10 plus I3. So I3 is equal to 50 minus 40, 10 milliamps. Okay? No doubt. Next, determine the current in all resistors in the given circuit. Here these three branches, three resistors are in parallel circuit. Across this, there is a current, 5 amperes. So, suppose V is the voltage across this resistor. V by 2 is I1. And I2 is equal to V by 1. V by 1. I3 is equal to V by 5. So by applying KCL, we have I is equal to I1 plus I2 plus I3. I is 50. I is equal to V by 2 plus V by 1 plus V by 5. So I is 50. 50 is equal to V into 1 by 2 plus 1 by 1 plus 1 by 5. Which is V into 1.7. So V is equal to 50 by 1.7, 29.41 volts. By using Ohm's law, you can find out the current in 2 ohms. I1 is equal to V by R1, I2 is equal to V by R2, I3 is equal to V by R2. So I1 is 14.705, I2 is 29.41, I3 is equal to 5.88. motor. Yes. Yes. For the given circuit, find the voltage across 10 ohms resistor, 10 ohms resistor, and the current passing through it. Okay. So assume the voltage at a node A. With respect to B, you can find out the current in 10 ohms resistor. According to KCL, according to KCL, 1, 1, 2, 3, 4 currents are leading currents, and this is entering current, and again this is leading current. So 10 equal to I1 plus I2 plus I3 plus I4 plus 5. By assuming B at node A and by using Ohm's law, I1 is equal to B by 5, I2 is equal to B by 10, I3 is equal to B by 2, I4 is equal to B by 1. So by adding all these currents plus 5 is equal to 10. So with this after simplification you can find out B. So I2 is equal to B by 10. No problem. So voltage across 10 ohms is voltage across 10 ohms resistor is 2.78 volts and current is 0.278 amperes. Okay. Determine the total current in the given circuit. So here these three resistors are in parallel. So find the equivalent resistance. So 1 by R is equal to R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Right? So R equivalent is equal to 1 by R1 plus 1 by R2 R3 R2. So 1 by R2 plus 1 by R3 plus 1 by R. That is equal to 1 mole. Now R1 and R equivalent are in series. So R total current, total resistance RT is equal to R1 plus R equivalent. So 5 plus 1, 6 times. So IT is equal to VS by RT, 30 by 6, 5 amps. Next problem. Find the current through R3. Given the voltage source supplies a current of 3 amperes. So assume the source current is IR1 and 2 amperes is flowing in this direction and current from R3 is I. So by applying KCL at this junction, IR1 that is 3 entering current, leaving current so minus 2 minus I plus 5 is equal to 0. So I is equal to 6 amperes. So current flowing through the resistor R3 is equal to 6 amperes. Next. 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 Okay. That's all for today. We'll see some more problems in the next video lesson.